And we want to welcome everyone. Let me get ourselves on camera so that you can see who we are. Okay, we are located at the Idea Stream, or I should say the Idea Center, in Cleveland, Ohio. We're downtown, right on Playhouse Square. How many of you know where Playhouse Square is? Raise your hands. All right, super. You've probably been down there for some programs, okay? And we are WVIZ, Channel 25. How many of you watch us on TV? Raise your hand. Oh, not too many. Oh, we need to have you raise your hands. All right, there we go. Super. Very good. Well, let me just put this preset in here, and then we'll get ourselves going. I don't know why everything was set yesterday when I left here. A mouse must have been in here doing something. Okay, well, again, good morning. I'm John Ramaco, the Director of Distance Learning Services here at WVIZ. And as you can hear, I have a very bad cold. So hopefully our presenters are going to do more talking than what I'm going to do. But we're here this morning to discuss 3D printing, okay? And 3D printing is a concept. It's not necessarily a new concept, but it's a new concept in manufacturing. And I would imagine if you would go back and talk to your grandparents about manufacturing, if they ever had jobs in manufacturing back in the 50s and the 60s and in the 70s and so forth, that they worked in large factories. In many cases, there wasn't a great deal of lighting. It was a warm place. It was a dirty place. There may not have been any air conditioning, and definitely no computers. And a lot of the work was literally done by heavy operating machines and equipment. Today, that's all changed, okay? And 3D printing is one of those major changes that we are now working with in the area of what we like to call advanced manufacturing. When I was a college student, yes, as a college student, I actually worked in a steel mill. And again, there were a number of us that worked for U.S. Steel. And I unfortunately ran a crane and became pretty adept at that. But we were manufacturing various types of steel products. And again, I was not looking at any type of a computer. We were looking at, again, an area with a lot of oil. We used to use what they call red rags to grab equipment and so on and so forth. And it was just not a very nice place to work. Today, that's all changed. If you go to a steel mill today, unfortunately, technology has taken away jobs, and that's the negative aspect of advancement in technology. But today, one person can probably do the same job that 10 did 40 years ago. So let me stop talking and let me introduce our guests, because I'm getting really squeaky here. And I'm going to put our guests on, and we're going to talk to them with regards to their background, their education, and where they are right now. With us, we have Ellen Howitt, if I pronounced that correctly, and Ellen is the project manager with the Technology House, which is a company that's located both in Solon and also in Aurora. Or Streetsboro, close to Aurora, all right, Streetsboro, and they are heavily engaged in 3D printing. Also with us is Alethea, I'll get it right, Alethea Ganaway, who is with the Workforce Community and Economic Development Division at Tri-C. Okay, ladies, let's talk a little bit about your background. Now, Ellen, you're actually from Kansas, if I'm not mistaken, correct?
Yep.
What brought you to the Cleveland area?
Specifically the biomedical art program at the Cleveland Institute of Art. One of the few in the country that has that as an undergrad program, and that was something I was really interested in because it combined art with science and technology.
Okay, and so you graduated from the Cleveland Institute of Art, and where did you begin your career here in the Cleveland area then?
I began working at a medical device and manufacturing company named Osteosymbionics, where we manufactured skull implants for people who had had surgery or cancer and needed an implant to replace a missing part of their skull.
Okay. And you've been now with the Technology House for how many years?
It's actually about 3 months.
3 months.
Yeah,
Okay.
I'm still new.
You're still a rookie on the job
Yeah,
then, right?
yeah.
Okay. And your responsibilities there?
It's, talking to customers, seeing what they are looking for specifically, and then being able to communicate the technology that I'm specifically working with and its capabilities, and then figuring out the best course of action, and then going through and scheduling and running the machines as well.
Okay. And what actually is the Technology House? What type of a business is it?
It is a machining and manufacturing company, so they do a lot of, like you said, additive manufacturing with stereolithography, and then what I'm working with, which is the carbon machines, as well as CNC machining, injection molding, things like that.
Okay, super. Thank you for being with us. Okay, I'm going to try this again. Alethea.
Yes.
All right, super. You're with Tri-C.
Yes.
And you actually graduated from Kent State University.
Yes.
All right. And what brought you to Tri-C then?
So I've been with Tri-C a few years, and I came to Tri-C with our robotics program. Then an opportunity opened up to work with our additive manufacturing program, which was just beginning.
Okay. And actually, if I'm not mistaken, you had a bachelor's degree in architecture from Kent State.
Yes.
Okay. What sort of changed the direction?
So I hold several degrees, and what happened was when I graduated with my degree in architecture, I couldn't find a job with that degree. The economy was pretty bad, and I had skills with engineering, and I taught high school students engineering, and I also work with the robotics program. So that's how I ended up coming to Tri-C, was because there was an opening in that program. Then eventually I moved into working with the additive manufacturing team.
Okay. And you're also a career coach?
Yes.
And what does a career coach actually do?
So I started off with the program working as a career coach. So I would help recruit students, do our marketing, outreach, try to figure out what students want to do, where their career paths are, help them with internships and job placement.
Okay. We're here to talk about advanced manufacturing and with a specific topic of 3D printing. So, ladies, what actually is 3D printing?
Do you want to give a definition or should I?
You can go ahead.
Okay, 3D printing. So 3D printing is very, everybody's seen a 3D printer. Everyone's seen it on TV. It's actually you take a three-dimensional image that you make in a computer software. I don't know what you use in your schools. Some schools I know use SketchUp, even at your age in middle school. Once you have that model that you made in the computer, you can actually send it to a printer, and it'll print you a physical object. Like all of these objects that are sitting here with me on this table were 3D printed.
Okay. And we actually we have a number of things. Why don't we just hold them up to?
So this drone, we actually 3D printed the structure of it. We actually bought the propellers. We have this leg. This is actually a 3D printed prosthetic. You can 3D print jewelry. This is a bracelet that was 3D printed. And this is just an example of what 3D printing can do. What makes 3D printing really great and neat is that you can print an object in multiple colors and in one piece. So this actually has gears and you can move it.
Okay, very good. Now coming back to the technology house. Okay, you're a manufacturing facility. All right. So what are you manufacturing in at Technology House, and for what companies?
It's pretty much anything you can think of: medical, consumer, toys, cars, just pretty much anything you can
Okay.
think of.
Now, are these all prototype, or are they, in a sense, finished products that are going to be
Both.
sold and used?
Yep, both.
Okay. What is a prototype?
A prototype is if you're planning out a project or a big idea, you always want to start with a preliminary design, and they'll want to see that and touch it and interact with it. And so that's the prototype stage where they're just getting their initial ideas made so they can test it out and see if that's the direction they want to go
Okay.
in.
And again, what's the advantage to 3D printing in manufacturing? Is there an advantage?
Yes, its speed is number one. And then also with some of the new technologies that are coming out, you can print things that you wouldn't necessarily be able to make any other way. Like with injection molding, you couldn't make some of the things we're able to make through additive manufacturing.
Okay. And Alethea, what's the draw now to Tri-C? What is your program there?
So we have a 1-year certificate of proficiency in additive manufacturing. Out of any of the 2 or 4-year colleges or university in Northeast Ohio, we are the only school with this program. We get students from all different backgrounds. We have engineers, artists, variety of people that come into this program so that they can learn about additive manufacturing. They can learn how to make 3D models. They can learn how to 3D print, and any technology that's basically related to additive manufacturing.
Okay. And then coming back to the technology house, some of your employees or many of your employees have other various backgrounds, art, design, engineering, a multiple group of individuals. With regards to the products that are being used in, we don't have any examples, but what are some of the products that you actually produce that are out there today being used?
We produce, it's for what I work with specifically, I'm more centered just with this one specific 3D printing type of technology. We are working on getting some production out there, but right now we're mainly prototyping. But again, it's a huge,
You name it.
yeah, you name it.
Okay, super. Well, let's show a very short clip here on 3D printing, and then we'll take questions from our students. So I'm going to bring this up, and we'll get it up on the monitor for you kids here.
3D printing is a tool we use to try and get the idea basically out of your head into your hands. So what we do is use a couple tools. One of those is a CAD system, so computer-aided design, to actually take the design it in the computer. And then after the design is finished in the computer, we take it and send it to a 3D printer where we can actually print out parts like this.
It's been said that anyone can print anything, anywhere, with 3D printing or additive manufacturing. Industries that are leading the way in adoption of additive manufacturing would include aerospace and defense and automotive and biomedical. But the opportunities and the applications can be for any industry.
You can print a small little part like this, or even smaller with additive manufacturing, all the way up to printing customized furniture.
Additive manufacturing is scalable, so we can print very small parts, and we can also print parts as large as a car, even as large as a house. We're seeing significant growth opportunities, significant knowledge being developed that's going to enable manufacturers to take advantage of this technology and mainstream it as a common manufacturing process in the next 3 to 5 years.
For me, what's exciting about this field is removing the limitations, really. We can print with metal, we can print with plastics, we can print with rubber, different colors together. The sky's the limit, really, right now on what we can do.
Okay, very good. Let me get us back on camera. All right, there we go. With regards to the materials themselves, talking about printing with plastics, resins, I guess, and metals. Okay, a very quick process or a very slow process?
As far as plastics go, it's very quick. Very quick. So it can range anywhere from 5 minutes to 12 hours to 30 hours, depending on the process, but very rapid.
And the printers then, how large are they? And is it an expensive piece of equipment?
It ranges again, so you can have smaller, the MakerBots that you've seen, up to really, really large SLA, FDM machines. And again, it ranges in price from more consumer level to the manufacturing side, which it's not, you know, it's much more expensive.
And the individuals who are running those now, are those designers? Are they machinists? Are they engineers?
It's a mixture depending. Some are engineers, some don't have any training. I didn't have any manufacturing training and I was operating them for a while. So again, there's a big variety of people that are able to work with these.
Okay. Alethea, as a career coach, then you're encouraging students to come to Tri-C and to get involved with your program. What's the job market out there right now for kids going into advanced manufacturing?
So I really only work with additive. I don't do a lot with subtractive manufacturing. I will say if you want to go into manufacturing in general, it's not what everybody thinks. A lot of times people think it's this dirty thing. You're going to go to work and get dirty, and that's not true. Manufacturing has evolved. They need people that have more skills and education. For additive manufacturing, you don't see a lot of jobs in it, but it's an add-on to something you can already do. So if you're an engineer, knowing additive manufacturing is definitely a plus. If you work in the medical field, it's definitely a plus. And I don't always think that people really take into consideration the great opportunities you can have in manufacturing.
The problem is, maybe we can just say it's sort of a continuing education process. As technology develops, you improve your status and your education, your knowledge by moving into a new field. And this is a new field, is it not?
It's been around since the 1980s. I don't think that people really realize how long it's been around. But it's really become popular, I would probably say maybe in the last 10 years or so, because of the commercialized printers like the MakerBots, Ultimakers, Maker Gear, which is a local company here in Beechwood, Ohio. I think that's why people see more of it, and you see people on TV, oh, I printed this, and they're in their house, and it sounds great. But a lot of times people don't realize there's actually education behind it, that there's different types of materials that you use. It's an engineering process.
With regards to courses that our students might be interested in taking, and again, we're talking to sixth graders now, and looking at perhaps getting involved in this 6 years down the road. What are some of the courses that they might want to consider as they move towards high school?
Definitely math. So all of our courses are engineering technology. They're not, so a lot of times people think because it's additive manufacturing, that's all you learn, and that's just not true. It's more, we have engineering courses, so you want to make sure you're really strong in math. I would probably say that's a big one.
Okay. And Ellen, in your situation, though, you were, in a sense, an artist, okay, and had the opportunity. Did you have to go back to school for any additional work?
I have not, no.
You're not, okay, super. That's great.
But what I did have was a lot of training with 3D design, which really helped a lot to understand.
Is there a particular software that students right now might be able to utilize on their own computers to get themselves interested in this particular type of career area?
I know there's a lot of different.
They can use SketchUp. What I always recommend when I work with schools is that you can use SketchUp. It's a free program that anyone can download. Teacher out there, you can actually get the SketchUp Pro for free as a teacher. And you can, in order to print, you need to print an STL file. And there's actually a extension that they can export it to do an STL file. And SketchUp is pretty easy. I've taught it to young students, so.
Okay, very good. Well, we've talked enough, so let's hear from our St. Ambrose students. So we're going to open up, if you open up your microphone, we'd like you to introduce yourself with your first name and then ask your question, if you would, please. And then put your microphone back on mute so that we can do away with any type of an echo that might be as a result of our audio connectivity. So let's take as many questions as we can. Who's up first?
My name is Allie, and I would like to know if you can print Like, what's the most common things printed in the 3D printer?
The most common thing right now we're doing, it's mostly prototypes. So we've done a lot of toys recently. We've done some things for medical prototyping. Those are probably the most two that I can think of off the top of my head. But anything you can think of, we've printed probably.
Yeah.
What are some of the toys?
Like dolls, action figures,
Okay.
things like that.
All right. Another
Hi,
question.
I'm Taylor. Hi, I'm Taylor. My question is, do you have to put the products in the machine that you're going to use, or is there already products in the machine?
Shit. What did she say?
If you have to put the products in the machine.
So you know how you type something on the computer and then you press a button and it prints out and it's on a piece of paper? That's pretty much how you do a 3D printed model. You take a solid model that we make in a computer and then we can print it out and we actually get a physical object.
And in watching that machine work, it actually goes back and forth.
Right, that's why it's called
Back and
additive
forth.
manufacturing, because you're adding layers of material on top of each other.
And in some cases, it's a heat process or a heat procedure, is it not? Or laser?
Yeah.
Is it laser?
Both.
Both. Okay. Another question.
Yeah.
My name is Alex, and my question is, what would happen if you could print a 3D printer with the 3D printer?
You would have another 3D printer. You can actually do that.
Yeah, we specifically, we've actually printed parts for our printers. So we've been doing that.
You can actually print movable parts as you indicate or shown here with the one item that you have here. Okay, good questions. Another question for us, please.
Hi, I'm Mikey, and I wanted to ask, does the size of a printer matter? Like, does it matter how big the object is you're printing?
Yeah, so the bigger the printer is, the bigger the part you can print, essentially.
And for example, this piece right here, it's pretty big. Our printer wasn't big enough to print it all in one piece, so it's actually 3 different pieces put together.
Going back to automotive parts or parts for airliners and so forth, what is the largest piece that you're aware of that's been printed?
Boeing prints parts, but they don't print parts that are needed. They're just small parts. They're not
Okay.
something that really you need for the airplane to be
Okay,
functional at this
it's not
point.
the skin of the airplane.
Plane, no.
No, it's
They're
mostly
just
like
small,
buttons and little extra features, things
There's-
like that.
minimal.
Okay, and how about with cars then? Are they printing a fender or a bumper?
Not yet.
Not
But they
yet.
do have a 3D printed car that I got to ride in. Yes.
You really?
Yes, we had it at our conference. It's called the Strati, and it actually was printed through subtractive and additive manufacturing. And I got to ride it. It was a very bumpy ride.
Another question for us, St. Ambrose.
Hi, I'm Kira. On regular printers, you can make copies of different papers. Can you make copies with 3D printers?
Essentially, you can print the same part as many times as you want. So as long as you have that 3D file, the 3D object that you've made in the computer, you can print it as many times as you want.
And to make an adjustment to that particular object, you just have to change
The original
original,
file, which
right.
is again why 3D printing is pretty exciting, because you can change it piece to piece essentially if you want to.
Another question.
My name is Kate, and my question is, will the 3D printer be able to go in a factory?
Yes.
Yeah, that's I essentially work in a factory, basically. So, yep. And I know a lot of other larger companies have additive manufacturing machines of various kinds that they have in their own buildings. So,
Do you have a 3D printer at your school?
No, let's put it this way, not yet.
Not yet.
Well, yes.
Not yet.
We're getting
All right, Alex, one more.
My name is Alex, and my question is, could you make stuff like, can you make like liquid objects in the 3D printer?
No, you can't make liquid objects, but they do print. They do have 3D printers that print food. Hershey's has a printer that prints chocolate. Hershey's has a printer that prints desserts.
3D printer that prints.
They prints candy. You can't buy it because I tried to buy one.
Chocolate.
Yeah, you can. And there's another 3D printer that prints food called the Food Printer.
Okay. All right. Okay, we've got time for. Okay, you have a couple more questions.
Anybody have any more questions? Allie, one more?
Should I say what again?
Yeah.
Oh, okay. What's the best printer to get like the size-wise?
Are you buying this for your home?
No.
Or just well, there's really small printers that you can print small items like this, and there's other printers that are very, very, very large that you can print furniture in. So it just depends on what you want to print.
All right.
What is the best,
My name is Evan.
Oh, my name is Evan, and who created the 3D printer, and like how do you know to create that?
Okay, what's a little history? Who created a 3D printer?
I believe it was Charles Hall was the invented the first 3D printer, if I'm not mistaken. Yes, I am correct. It was Charles Hall created the first 3D printer.
And that was back in the 70s then, or 80s? Okay. All right. One more question. You have another question?
All right, one more question. Amanda, you don't want it yet.
My name is Amanda, and I want to know if you can print two different materials, like in the 3D printer together, like at the same
Oh,
time.
okay.
Yes, yes, you can. They do have printers that you can print two different types of materials. We don't own one, but they're very nice.
Okay. Well, we're just about finished here, but I want to ask our two guests. These kids are sixth graders, okay? And in the next 6 years, there's going to be tremendous development in technology, tremendous advancement. What do you see future-wise with regards to additive manufacturing and 3D printing? Where are we going to be in 6 years' time? Can you mute your microphone, please?
So, in 6 years, additive manufacturing will definitely increase and there'll be more demand. I always say I think the biggest impact is going to be in the medical industry, because in the future you may be able to 3D print hip replacements for someone that's unique versus is it small, medium, large. You can 3D print someone a new knee versus the traditional ones they have. So I think that's where you're going to see the biggest impact. And even like for example, China is 3D printing buildings now. So.
We need to step our game up.
We need to step it up.
Okay. All right, St. Ambrose. So we want to thank you so much for joining us. And I know there's going to be another class in here for our 10 o'clock program. And I hope we provide you some information on 3D printing. If you have any questions about the program at Tri-C and or with the Technology House, go to their respective websites, and there's a great deal of information there that they will share with you. So again, thank you for joining us, and hopefully we'll see you for another one of our programs. Bye now.